Let's jump into the first major factor that affects the glomerular filtration rate, the capillary hydrostatic pressure. This is one of the main driving forces behind filtration. In the glomerular capillaries, there is pressure ranges between 45 and 60, which is way higher than the pressure in normal systemic capillaries. Now you might ask, why is it so high? Well, there are two important reasons. In systemic circulation, capillaries drain into venules, and the capillary hydrostatic pressure ranges from 15 to 35. On the other hand, glomerular capillaries are drained by arteriole. Venules have much lower hydrostatic pressure in comparison to arterioles. The efferent arteriolar hydrostatic pressure is about 42. For that reason, if the glomerular capillary had lower pressure than 42, there would be no blood flow. Reason number 2, the renal arteries supplying the kidneys are short, narrow, and come straight from the abdominal aorta. Because of their short, direct, and relatively small structure, there is less resistance and higher pressure is maintained, which supports strong filtration throughout the glomerular capillaries. Next up, the oncotic pressure. This refers to the osmotic pull exerted by plasma proteins, especially albumin, that draws water back into the capillaries. Let me break it down. If this is our capillary, blood enters the afferent arteriole and exits through the efferent arteriole. As filtration happens, fluid leaves but the proteins stay. So what happens? The protein concentration increases as blood moving along the capillary, which means oncotic pressure rises. At the afferent arteriolar end, the oncotic pressure might be around 25. But by the time blood reaches the efferent arteriolar end, it can rise to 35 or even more. This increasing oncotic pressure acts against filtration, and it's one of the reasons why glomerular filtration rate isn't just sky high all the time. There is a balance.